Hey, my name is Andrew Tremblay, and this is Lab 4 for Physics 1. In this lab, we measured the motion of a mass on a spring, um, first through Tracker, and then we made a model through WebPython. Through WebPython, we would just use real-world values that we initially got, plug them in, and then also use some basic principle calculations to determine what the motion should be, um, like in a perfect world, like without friction. Um, so the hardest part of this was getting L0 because I had a long trouble with this. Because L0 initially gives you as zero point 0.7. However, that's with the mass hanging down and the force of gravity acting on that mass. So we subtract that force being applied, or the distance that the force of the mass, or the distance the force of gravity causes the spring to stretch, minus LO to find the actual equilibrium length of the spring facing down. Um, First, in this comparing section, um, we have the Y position versus time. The blue is the model and the red is the experiment. The model has higher peaks on both ends, um, which I would think is due to it not losing as much energy, as well as I think the starting position was a little bit off on the experiment in the model, even though the actual data did start at the same one in the model as the experiment data gave us, but I guess when we put the files in, it does something weird. Um, but the peaks kind of showed what the data would look like anyways. So I think it's losing energy due to friction. Same kind of thing on the very far right, although I don't think it's the same amount. I think that it's more due to a measuring error because they look almost identical in almost every sense. There's just a few like hiccups here and there, and it's kind of shifted to the left or a little compressed. Um, but in the middle, this is what the model shows is that there is no energy loss as the delta E just is at zero the whole time. Um, and the motion of it, this kind of ties into what does this mean? Um, yeah, the energy principle is satisfied because all the energy is conserved. It's not going anywhere. That's why delta E is 0. Um, Although delta K does decrease, it's because it's going to here, and I can get out of here and show you why right here. Too far. As you see, the ball starts here, and then kind of starts going further and further away, which kind of decreases the delta K. It kind of keeps it more constant as it goes into more constant motion. So the change in K won't be as much, but the uh, kind of as well as the other two, but just not as noticeable because as it goes towards more of a circle, it's gonna kind of maintain the same speed, therefore same kinetic energy. And finally, the difference periods of the two y and x, they're almost identical at 1.5 seconds. Um, that's because, as I said, the spring's kind of trending towards becoming a circle, and that would make sense because in a perfect circle, they would be exactly identical, the periods. Um, and also, the spring doesn't really care what the orientation it's in. Um, for it to complete a full loop, it will take the same time for both directions of the oscillation.